Hello, Assalamu alaikum, and good evening, everyone. Now I am going to start with the lecture 12 on the topic of thanatology. And this topic will continue the rigor mortis, which I was discussing in the previous lecture. And in this lecture, we will discuss how the rigor mortis help us in estimation of time since death. Then we will also discuss what are the factors which are responsible for appearance of rigor mortis, and as they are most important in its development, like the degree of muscular activity at the time of death, the glycogen reserves at the time of death, the temperature of the environment, the state of nutrition, and other factors which are responsible for the development of rigor mortis. Then we'll also discuss the graphical representation, or we plot a graph regarding the rigor mortis development. And then we will discuss the differential diagnosis, that the conditions which simulate rigor mortis, and we'll try to understand and distinct these features from the rigor mortis. So starting with the 12th lecture on thanatology about the rigor mortis. Thank you. Hello, Assalamu alaikum. Now I'm starting with the 12th lecture of thanatology, which is the continuation of the topic of rigor mortis. Bismillahirrahmanirrahim. The learning objective of this lecture will be that after this lecture, we will be able to understand what are the parameters which are concerned with the estimation of time since death relating rigor mortis. That how rigor mortis helps us in estimation of time since death. Then what are the factors which affect the development of rigor mortis? Like the degree of muscle activity at the time of death, the glycogen reserves in the muscles, the temperature of the environment, the age, and the nutrition of the body are the most important factors in the development of rigor mortis. Then we will discuss the graphical representation of the rigor mortis, how the graph is plotted in the rigor mortis. Then we will discuss the differential diagnosis of rigor mortis, that is the conditions which simulate rigor mortis, and they should be distinct from the rigor mortis. And these conditions which simulate the rigor mortis, they are the cadaveric spasm, the heat rigor, cold stiffening, and PUTREFACTIVE system, PUTREFACTIVE stiffening. So continuing with the topic of the rigor mortis, now we'll discuss the rigor mortis as a parameter to determine time since death. As we know, the rigor mortis is an uncertain and unreliable criteria in the estimation of time since death. And this we have discussed in almost all the changes. And these all changes should be taken in conjunction, that all the changes should be taken into consideration simultaneously. Then we can estimate the time since that no individual change soul can help you determining time since death, because there are certain factors which alter its progression and stay. So similarly, the rigor mortis is an uncertain criteria in the estimation of time since death, because its progression depends upon certain factors which are within the body or in the environment. And we know that this development is 12 plus 12 plus 12, which means the craniocaudal development, that head to toe development, it takes 12 hours to develop on. Then for 12 hours it will stay, and in next 12 hours it will pass off in the similar fashion from head to toe as it has developed. So which means the rigor mortis take 12 hours to develop after death, stays for 12 hours, and in next 12 hours it will pass off. But there are certain factors which affect the rate of onset and duration of rigor mortis. So factors which affect the development of rigor mortis, this is putrefaction, it is mistyped. The one factor which is most important is the degree of muscular activity at the time of death. Then the environmental temperature, age, and the glycogen reserves within the muscles. So these are most important factors which are responsible for the development of rigor mortis after death. So degree of muscular activity at the time of death means that if a person is having a prolonged muscular activity, the glycogen reserves, they may be depleted, like the deaths due to drowning, convulsions, or exhaustion of a person in of a army man in a battlefield. So because of prolonged activity, his glycogen reserves have been depleted. And the onset of rigidity in such situation will be rapid and duration will be short. So it's a general rule that when the rigor sets on early, duration is short. The relative absence of muscular activity like sudden death, the rigor mortis is delayed and the duration will be prolonged. Now the environmental temperature plays an important role. When the environmental temperature is raised, the onset of rigor mortis is accelerated and duration will be short. And if the temperature of the environment is low, then the rate of development will be slowed down, and then the duration of the rigor mortis will be prolonged. Then regarding the age factor, it appears early in the infants and the babies and also disappears early because the infant and the baby, they are small muscles, small glycogen contents, so the rigor mortis will be developing early and then pass off early. Similarly, in old people, the onset is rapid than the adults. In old people also there is muscle wasting and the reserves are less than the normal adults. Then about the glycogen reserves, the rigor mortis is also dependent upon the glycogen reserves of the muscles. If the reserves are more, then the development will be delayed, and the reserves are less, then it may start up earlier as the deaths in prolonged and chronic illnesses. And this is also the reason that it develops first in the short muscles, then the large muscles, because the short muscles have small glycogen contents than the large muscles. So the rigor mortis is evident early or first in the small muscles of the face and the eyelids, and then to the neck and lower down because the limb muscle, they are larger and having more glycogen reserve. Regarding the time period of progression, we have discussed previously that it is early in summer, late in winter, and it starts approximately 2 to 3 hours after death. And these 2 to 3 hours is that time during which anaerobic glycogenolysis is going on, which is responsible for maintaining the core temperature of the body and keeping the body in a relaxed state. And then it starts developing in the face first, the eye muscles, then the mouth, neck, upper limb, lower limb, and it takes 12 hours to completely develop rigor mortis from face to the toes. Then it stays for 12 hours and then it passes off in next 12 hours in the similar fashion as it has developed from head to toe. So that's why this time estimation is called as 12 plus 12 plus 12. The first 12 means 12 hours in its development. Plus 12, second 12 means for 12 hours it maintains itself. And next 12 hours mean in next 12 hours it will pass off from head to toe. Then regarding the graphical representation of rigor mortis, this is how when we plot a graph, it appears that for initial few hours there is no rigidity. Then it starts developing and it takes 12 hours to develop. And then the horizontal red dotted line shows from 12 to 24 hours, that is 12 hours during which it maintains, and then 24 to 36 hours, that is the next 12 hours, it passes off. So that's how we plot a graph for rigor mortis. Then the differential diagnosis of rigor mortis. The conditions which simulate rigor mortis, they should be differentiated. So the conditions which simulate rigor mortis, they are the cadaveric spasm or instantaneous rigor, heat rigor or heat stiffening, then cold stiffening or cold rigor, which is due to freezing, and putrefactive stiffening, which is due to accumulation of putrefactive gases. So this is false rigidity. So the cadaveric spasm or instantaneous rigor, it is said as the record of last volitional activity of a dying person. It is record of the last volitional or voluntary activity of the person at the time of death. And there are certain prerequisite conditions. So it's a form of muscular stiffening which occurs at the moment of death, and muscles without going into primary flaccidity becomes rigid. And it will persist until the stage of secondary relaxation, which is the beginning of putrefaction. So it is a recording of the last volitional activity before death. Its cause is unknown, but it is a vital phenomena, and it originated by the normal nervous stimulation of the muscles. It is usually associated with violent deaths in circumstances of intense emotional stresses, the rigorous physical activity like the fighting soldier or during war, or drowning, or from mountain fatalities, or in certain suicidal deaths. The person is in extreme emotional stress, and the muscles, a group of muscles, they immediately goes into rigor and stiffens and records the last volitional activity. The person falling from a mountain during the fall can grasp the shoots of the tree and they remain grasped in his hand. Or the drowning person can grasp the sand or other weeds in its hand which remain be clenched within his hand. And similarly, if this person performing or doing suicide, the weapon may remain grasped in his hands. So this is the record of last volitional activity at the time of death due to extreme, intense emotional states. Fatigue plays an also important factor in certain cases. The cadaveric space has a medical legal importance because it records the last act of life. So it gives an idea about the cause and the manner of death. It affects all the muscles of the body, but most commonly involve the single group of muscles such as muscles of the forearm and the hands. The examples: in drowning, the victim may hold a bunch of beads in an attempt to save himself, and they remain clutched tightly in the hands. Or a person committing suicide may grip a pistol in his hand and the weapon is firmly grasped in the hand at a moment of death. But this condition should not be diagnosed unless the grasp is tight, because this cadaveric space is so tightening that with extreme force you cannot relieve it. It is so tightly clenched. Criminal may put a weapon in the hand of the dead body and may disguise, and due to rigor, it may be contracted. Then the grip will not be as tight. You can easily remove the weapon by applying a little force, but in case of cadaveric spasm, it is usually not possible to release the grip. Similarly, a bunch of hair can be in hand of a victim during suicide scuffle. Or in mountain fatality, the shrub, the shoots of the trees, they are uh, held up in the hands and they act as a proof of the mountain fatality. These are few photographs showing the grasped weeds. This is in drowning. So the difference of the rigor mortis and cadaveric spasm: regarding the time of onset, rigor mortis, it develops approximately 2 to 3 hours after death, whereas cadaveric spasm instantaneously develops at the time of death. There is predisposing factor which is responsible for the cadaveric spasm, like the sudden death, extreme emotional states, but in rigor mortis, no predisposing factors. Then the muscle involved in rigor mortis, all the voluntary and involuntary muscles are involved, whereas in cadaveric spasm, a group of voluntary muscles are involved, usually the forearm or the hand muscles. Then the muscle stiffening in rigor, not marked, moderate force can break it. But the cadaveric spasm, there is marked rigidity. Moderate force cannot break it. Regarding the medical importance, the rigor mortis helps in determination of time since death, whereas the cadaveric spasm also indicate the nature of death, that is suicide, homicide, or accidental. Then the body temperature, in rigor mortis, the body is cold, but in cadaveric spasm, the body is still warm for initial 2 to 3 hours, because a group of muscle which has gone into spasm, they may be a forearm or the hand, and the body is still warm. Then the molecular death, it occurs in the rigor mortis. In cadaveric spasm, it does not occur. The electrical stimuli do not respond in rigor mortis to electrical stimuli, whereas the cadaveric spasm, the muscle respond to electrical stimuli. The mechanism in rigor mortis is known because there is a chemical basis of the rigor mortis, but in cadaveric spasm, it is not known. Now, the heat stiffening, this is because of extreme heat and the proteins of the muscle, they get coagulated. And it is seen when the body is exposed to intense heat, like temperature which are higher than 75 degrees Celsius or higher, as in burning or immersion in hot liquid, or when the body is exposed to high voltage current, there will be coagulation of protein. The proteins are coagulated and stiffened. But unlike rigor mortis, they are showing the color of vital reaction. There is heat stiffening and considerable shortening of the muscle, and this stiff is they stiff, but they can tear, they can be torn easily because they have been solidified by the heat and they are easily torn. And due to this, the muscle shortening, the body assumes a characteristic attitude, which is known as boxing attitude or pugilistic attitude, because the whole muscle, they are undergone coagulation and there is stiffening of the body. Like this, the body is burned and appears a boxing attitude, and in which there is generalized flexion of the body, especially the knee, elbow, and the neck. The hands are also clenched. These changes have nothing to do with the cause or the manner of death, because it has been seen that if the death may be from any cause, if there is post-mortem burning immediately after death, then the protein of these muscles will also be solidified or coagulated, and the body will also assume pugilistic attitude. So because the heat trigger usually develops in those cases where the bodies are deliberately burned after the death in order to conceal the cause of death or identity. So this pugilistic attitude has seen if the body is burnt immediately after the death. The rigor mortis does not develop in these muscles, which undergo stiffening by heat coagulation. Heat stiffening persists until the muscle undergo putrefaction. Then the cold stiffening. This is a rigidity due to freezing temperature of the environment. So any reduction in the temperature of the body below 3.5 degrees Celsius or 40 degree Fahrenheit, it will produce a volatile solidity of the subcutaneous fluid and muscles, as we have seen the freezing in the freezer. When we put something in freezer, its fluids are solidified. And conditions simulate rigor mortis, but the body will be extremely cold. This rigidity is actually cold stiffening and cannot be broken by applying force. And it gives crackling sound of frozen synovial fluid at the joints, just like breaking the ice. If you try to break, there will be a crackling sound as the ice is being broken. And if the body is exposed to cold, this stiffening usually develops before the onset of the rigor mortis. When the body is exposed to extreme temperature, this stiffening develops even before the rigor mortis, means the body does not undergo primary flaccidity and immediately develops the cold stiffening. And this rigidity is due to cold, and it can be lost when the body is put in higher temperature. The body will be, muscles will be relaxed. But again, if you subject the body to low temperature, it will again be frozen. So it appears quickly and disappears quickly because of the temperature. If the temperature is low, it will appear quickly, and if the temperature is raised, it will disappear quickly. Then the putrefaction stiffening. This stiffening is because of the accumulation of the putrefactive gases. And this stiffening is false stiffening. There is formation of gases in putrefaction, and accumulation of these gases will cause stiff limb, which is a false rigidity. The rigidity of putrefaction can easily be differentiated because there will be foul smell and other features of the disintegration will be seen. And the medical legal importance of rigor mortis. Rigor mortis helps us in calculating time since death. It helps us in determination of the position of the body at the time of death. Then the graphical representation of now all the changes, that is postmortem staining, cooling of the body, and rigor mortis. You can see these three changes. The purple graph is of the caloricity or the cooling of the body. The light purple is the lividity, and the red dots are the rigor mortis. So this is a graphical representation of the post-mortem changes, which are the early changes. And usually a question comes in university that plot a graphical representation of the changes which appear after death. And the summary of this lecture is that after this lecture, we have understood the rigor mortis as a parameter of estimation of time since death. When we want to know that the body is in full rigor, we'll simply move its big toe, the big toe of the foot, because that is last to go into rigor. If it is fixed, that means 12 hours have passed and 24 hours can be fixed and not 36 hours because it has not passed over. So we can give, if the big toe is in full rigor, we can give or estimate a time of 12 to 24 hours. And by other muscle changes, we can estimate the parameters if it is in developing state, fully developed, or in passing off state. That 12 hours, 12 hours, 12 hours, 12 hours are development, 12 hours of stay, and 12 hours are passing off will tell us in estimation of time since that. So simple parameter, we move the big toe. If it is stiffened in rigor, we can give the range from 12 to 24 hours. Then we discussed what are various factors which are responsible in the development of rigor mortis, like the muscular activity at the time of death, the temperature of the environment, the glycogen reserves, and the age of the deceased. Then we graph the temperature of rigor mortis, and then we discuss the graphical representation of all the changes. Then we discuss the differential diagnosis of rigor mortis, that the condition which simulate rigor mortis. That is the cadaveric spasm, the heat rigor, the cold stiffening, and putrefactive stiffening. And we have learned what are the contrasting and distincting features which distinct rigor mortis from these changes. Thank you very much. So that's all for the lecture number 12 and end of the rigor mortis topic. Thank you very much.